the last video, we talked about these three primary trig functions, and we talked about how from the perspective of angle A, if we're looking at that angle, the opposite side is the side farthest away from that. And so the sine of angle A is the opposite divided by the hypotenuse. However, if we were not looking at this from angle A, if we were instead looking from angle B, notice what was considered the opposite side and the adjacent side swapped. So previous slide, adjacent's here at the bottom, opposite is the farthest away. And here we have opposite and adjacent switching places because we always look at it from the perspective of the angle that we're taking the measurement of. So the definition for sine, cosine, and tangent remain the same. Opposite over hypotenuse, adjacent over hypotenuse, and opposite divided by adjacent. There are some ways to remember. The most common one is to remember sa, ka, toa. So what this stands for is sine of some angle is the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse, and tangent is the opposite divided by the adjacent. If that is not working for you, if you just don't remember it, there's some others out there. My favorite is one that my trig teacher shared with me, which is some old hag caught a hippie tripping on acid. There's your saw, sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. And remember, this is always from the perspective of the angle that you are taking the trig function of. We also have what are called reciprocal trig functions. Look how similar this is. The sine of angle A is the opposite divided by the hypotenuse, and this is called the cosecant. The cosecant of angle A is the hypotenuse divided by the opposite. Cosine is adjacent divided by hypotenuse, and secant of angle A is the hypotenuse divided by the adjacent. Tangent, opposite over adjacent, cotangent, adjacent over opposite. As you can see, these three reciprocal trig functions are just the reciprocal of sine, cosine, and tangent, respectively. I remember that tangent and cotangent are related because the name is so similar. But otherwise, for remembering that sine goes to cosecant and cosine goes to secant, I remember that whatever starts with a co doesn't end up with a co, and vice versa. Let's use these trig functions in one problem. Let's say we have the following triangle, and we want to find the sine of angle A and also the sine of angle B. Say we have the sine of angle theta. Theta is just a Greek symbol that is kind of a stand-in for just a general angle. So the sine of angle theta I know is the opposite divided by the hypotenuse. So from the perspective of angle A, the opposite side is side length 9, and then the hypotenuse is 25. So the sine of angle A is the ratio 9/25. Now let's look for the sine of angle B. From angle B, the opposite side is not 9, the opposite side is this unknown length. What we're going to do to find that unknown length is use the Pythagorean theorem. So side length B, right down here, is going to be the square root of the hypotenuse squared minus the other side length squared. And that is just the Pythagorean theorem manipulated to solve for side length B. I ended up with B is approximately 23.324. I don't know if we want to leave it that exact considering our other numbers are 25 and 9. Let's leave it as 23.3. So B is approximately 23.3. Now to find the sine of angle B, now I have that side length of 23.3. There's our opposite divided by the hypotenuse of 25. So this is not yet solving for that angle B. We'll do that in the next video. But this is just describing what that ratio is. We could have also left it as a perfect square root, because this is the same thing as a square root of 544. Continuing this problem, let's find the cosine of angle A and the tangent of angle A. And again, I'm going to be using that value of 23.3 for side length B. The cosine of some angle is the adjacent divided by the hypotenuse. From the perspective of angle A, the adjacent side is the non-hypotenuse length that it's connected to. So 23.3 divided by the length of the hypotenuse, so divided by 25. The tangent of angle A is the opposite divided by the adjacent. So the opposite is 9, the adjacent is 23.3. Thank you.